Okay, so we've got another group of reduction formulae. Now these formulae, they are called cofunctions or corratios. Okay, they've got two names depending on the source that you'll be using. Either we can call them, just give me a second. Alright, so we call them corratios. So number one, sine 90 degrees minus theta is equal to cosine of theta. Cos 90 degrees minus theta is equal to sine theta. And sine 90 plus theta is equal to cosine of theta. Okay, you are expected to memorize them. Sine 90 minus theta is equal to cos theta. Cos 90 minus theta is equal to sine theta. Now, you need to be aware that theta is acute here. Okay, theta is acute. For all your reduction formulae, the theta is acute. Okay, also you have sine 90 plus theta, that's equal to cosine of theta, and cos 90 plus theta, that's equal to negative sine theta. Okay, so these four, we call them the cofunctions or corratios. Those four.
So when sine is 90 plus or minus theta, it's always cos.
Yes, the corratios, they convert either sine to cos or cos to sine. No tan is involved here.
So if it's cosine, tan 90, it's just sine.
There are no corratios for tan. Right? The main reason is because if you remember last year when we were first introduced to trigonometric ratios, right? We were introduced to trigonometric ratios. When you were drawing the graphs of sine and cos, okay, I remember telling you that the graph of sine and graph of cos are the same. It's just that the graph of cosine is 90 degrees behind the graph of sine. So in actual fact, the graph of cosine and the graph of sine are the same. That's why both of them are sine caves. So they have a relationship. There is a direct relationship. So that direct relationship, it can be written in terms of an equation. Sine 90 minus theta, if this theta is acute, is equivalent to cosine of theta. No corratios for tan.
So if you explain number 4, why is it negative sine theta?
Okay, this angle here, 90 plus theta, it's in which quadrant? If theta is acute.
First.
No. It's in the second quadrant. Okay, let's say, for example, if theta was 20 degrees, it means you end up having cos 90 degrees plus 20 degrees, which will give you cos of 110 degrees. I'm sure you are aware that in the second quadrant, cosine is negative. Am I right?
Yes.
So, to get a ratio for cosine which is negative, you just have to take the sine of the acute angle and then multiply it by -1. That's why you end up having this minus sine theta. Because the overall ratio for cos 90 plus theta has to be a negative ratio. Okay? For this one here, if you put 20 degrees where there's theta, you get sine 110. In the second quadrant, sine is positive. That's why you can write this, the cosine of the acute angle, because sine is positive. All right? It's about quadrants. It's about your quadrants. In quadrant 2, cos is negative. So, if I want to write the ratio of cos 90 plus theta as a negative, okay, using sine, I have to put a negative sine theta, because sine theta is positive. So how do I make it negative? Put the minus there. Because this ratio here, it's always negative. I hope that over the days you've been going over your quadrants, because things are going to get a little bit hotter in the next coming days. Okay. All right, so we've got those 4. Let me introduce another group, yes?
So those are the reduction formula for 90 plus 1.
Yeah.
One of the first ones where we do the lines, are those the reduction formula for 360 and 180?
Those ones now, they incorporate other quadrants. Here we are concentrating on quadrant 1 and 2. Okay? But mainly dealing with sine and cos only, no tan involved. Okay? Alright. So we have got these 4. They are called core functions or core ratios. Right. Next year, when you do what are called compound angle identities, or rather, you might understand this better next year, but for now you have to memorize. Then another group is the reduction of a negative theta. Okay? Now, just to give you a recap of what you did last year, all angles in trigonometry are positive if they are measured from the x-axis in an anti-clockwise direction. So if you measure an angle from this point up to there, that's equal to theta. Okay? But if you do it in the opposite direction, that is clockwise, from the x-axis to the point in the 4th quadrant, like that, this angle here is going to be negative. Okay? Negative theta. So all angles are positive in an anti-clockwise direction from the x-axis. All angles are negative in a clockwise direction from the x-axis. Okay? Make sure you know that difference. So, if I give you, say, sine of minus theta, this minus theta here, it's an angle within the 4th quadrant. Okay? Because a negative theta is in the 4th quadrant. Because all angles are negative in a clockwise direction. So the sine of minus theta is a negative ratio. Therefore, we can write it as minus sine theta. Okay? Well, if you want me to show you how it comes about, I can show you. Right? I'll just show you for number 1, sine minus theta. Right? This is how you end up coming up with the answer. Like sine minus theta, we can write this as sine, okay, minus theta plus 360 degrees. I hope you are aware that if I add 360 degrees to minus theta, I'll come back to the same point. Okay, I hope you are aware of that. Okay, I hope you are aware of it. Okay, so if I'm in the 4th quadrant, if I add 360, I'll come back to the same point. So I can simplify that and write it as sine 360 degrees minus theta. And I'm sure you can agree with me based on the reduction formula that I introduced on the first day. This angle is in the 4th quadrant. It is equivalent to minus sine theta. So sine minus theta is equal to minus sine theta. Okay? We can do the same for cosine and also for tan. Okay? We just add 360 degrees. Go back to the original reduction formula that I introduced last week on Wednesday. And then we'll come back here. Right? So that's what I have here. So you also need to memorize this. Now, it's only for cosine. The cosine of a negative theta is equal to a positive cos theta, because in the 4th quadrant, cosine is what? Positive. So cosine of minus theta is the same as cos theta. Okay, but for sine and tan, you get a negative sine and a negative tan. Yes.
So how do you get a negative?
How do you get a negative what?
Negative theta.
Okay. A negative theta, if theta is any value which is acute, is measured from the x-axis in a clockwise direction. Okay? I hope that you are aware that from last year you did negative angles. All negative angles are measured from the x-axis going in a clockwise direction.
So this is negative theta, you know it's going to be.
Yeah, in this case here, when you are dealing with the reduction formula, the theta is acute. So if say theta is 20 degrees, if it's in the fourth quadrant, it becomes minus 20 degrees. If it's 50 degrees, it becomes minus 50 degrees. And that angle, as long as it's acute and it's negative, it will be in the fourth quadrant. If it was positive, it will be in the first quadrant. Yes.
So between which direction is it?
Yeah, I do. Can you come again? Why is it never mind? Talk so that we can clarify things.
I was just asking the interpretation of the direction.
When you are dealing with the reduction formula, the theta is acute. No, it's never more than 90 degrees. The theta is always acute.
So will always be the first and the last part?
No. Here, I was only trying to explain the concept of positive and negative angles. Okay, with respect to minus theta. Where is minus theta? In the fourth quadrant. It's in the fourth quadrant. Why is it in the fourth quadrant? Because theta, if it's positive, it's acute. Even if it's negative, it will be a negative acute angle.
So, has been other quadrant?
No, because theta is acute. If you put it here, theta won't be acute. Okay, because theta won't be acute. If you put it here, theta won't be acute. So it can only be acute in the first quadrant if it's positive.
And the last one?
And it can only be acute in the fourth quadrant if it's negative. Is that clear to everybody?
Yes.
Alright. So if you copy this down. Alright. Now then another concept. It's called the two fundamental identities. Okay? The two fundamental identities. So I'll introduce this concept, then in the next coming days we'll be doing questions on application now of all of this. Okay? Now the two fundamental identities, they are equations that are very important to trigonometry from grade 11 up to metric and beyond if you study something which involves math. Right? The two fundamental identities, they originate from your knowledge of trig ratios in the Cartesian plane. Right? So you know that sine theta is got y over r, cos theta is x over r, and tan theta is y over x. Okay? You know that. Okay? You also know that if you want to make y the subject, you get y equal r sine theta, x will be equal r cos theta. Well, we don't worry about the tan equation because it doesn't help us with regard to the fundamental identities. Now, when you want to carry on, you need to know that tan theta, after making x and y the subject, you can see that tan theta is y over x there. Okay? Tan theta is y over what? Over x. We can write tan theta in terms of sine and cos. Okay? By making y the subject in this equation, we'll get y equal to r sine theta. By making x the subject, we'll get x equal to r cos theta. Okay? The good thing about that is we know that tan theta is equal to y over x from grade 10. So we can substitute where there is y here, we can put r sine theta. Where there is x there, we can put r cos theta. The two r's will cancel out. You end up having a new equation, which is tan theta is equal to sine theta over cos theta. And this is one of the two fundamental identities. It's an equation. Tan theta is equivalent to sine theta over cosine of theta. Yes? Well, I'll use that later on, but the idea here is, do you understand how I got y equal to r sine theta? Then you square the left-hand side, you square the right-hand side. Yeah, that's how you get y squared because r squared times sine squared theta. Here again, if you square both sides, you get x squared because r squared times cos squared theta.
So it's not like a fraction like that, it's just a different one.
Yes, I think this was okay. On the next page, that's when I'll talk about it, but let me just remove it to avoid unnecessary confusion. Okay? Yeah. To avoid unnecessary confusion.
So, you know, so,
Okay. That's right. Just copy down y equals r sine theta. Okay, it comes from the first equation, y equals r sine theta, and that's x equals r cos theta.
sir, do we need to learn the whole process? Or can we
No,
just
no.
learn
The derivation, you don't need to memorize that.
just that?
You just have to memorize this equation.
Probably.
Some people can understand the concept of this two elements or I don't know.
The idea is you want to write, want to have an equation that has both tan, sine, and cos together. No more x, y, and r. So how do you come up with that equation? In the equation sine theta equals y over r, make y the subject. In the equation cos theta equals x over r, make x the subject. We know that tan theta is y over x. Therefore, where there is y there, we put r sine theta. Where there is x here, we put r cos theta. Then we simplify and come up with that equation. You see? The derivation is not examinable. If you feel that is too heavy for you, forget about it. Just master this equation.
So then why is it with the R sign? Basically taking that, substituting it.
Yes, we are substituting. Where there is y here, in the trig ratio that you know from last year, tan theta equal y over x. Where there is y, they are putting r sine theta. Where there is x, you are putting r cos theta. The two r's will cancel out. You left sine theta is the numerator, cos theta is the denominator. And you end up having a new equation. That new equation is the first fundamental identity. Okay?
The first
So then why does it have such a long name and why is it not just like another formula?
Don't complicate it.
No, math is complicated for no reason.
Sir,
Okay,
All right?
so what do we need to know this for? Just give us an example of
All right. How many of you can you remember that? Let's give you an example. You know that the gradient m is equal to y2. Just give you a bit of some background because trigonometry is very important, even in engineering, architecture, and so on. Right? It's a very important topic because it has got real life applications. So the gradient m is equal to y2 minus y1 over x2 minus x1. This can be written as delta y over delta x. Delta standing for change in y over change in what? In x. I hope you know that gradient refers to the change. Okay? In what? Change in what?
Isn't it graphs?
No, it's not only graph. I'm talking about in real life. You know that, okay, let's say for example, if you are constructing a road, okay, if there is like slope, goes up like that, right? The angle between the horizontal and the road, okay, when you are doing construction, you have to do a calculation of that angle. Okay? You have to do a what? A calculation. To do that calculation, you need trigonometry to do it. Because if the angle is too big, it means that the road is going to be too steep and cars will struggle to go up. Especially if the car does not have a very good engine and the power is not so good, it will struggle to go up, to roll back. Right? So engineers, they use trigonometry when they are constructing bridges. Okay? That's why to be an engineer, you need mathematics. Like, how many of you are doing physical science? Right? You, in mechanics, that's why you do mechanics. Right? In mechanics, you use trigonometry. Right? You do vectors. Okay? The concept of vectors is not enough without trigonometry. That's why you find the horizontal component and the vertical component. It's part of mathematics.
Sir,
Okay?
is that like the only, okay, that's the only way to write the formula, it won't change.
This one here?
Yes.
Yes, it won't change.
So,
Yes.
so you just have to have that one formula. Everything else above that is
Well, okay, let me just tell you what happens with this formula here. In most cases, this formula, we are going to use it to do proofs. Okay? This formula is not used to do proofs. Okay? But those proofs now, we'll do them later on. But it's mainly used for proofs. Don't worry, we are going to get there.
So you didn't ask me a question.
What's your question?
If it is necessary to know the information above it, or do you just need to know the formula?
Oh, the derivation is not very important. I think I said it already. I said that the derivation is not important. Just memorize the formula. Okay? Right, let me carry on. Then the second one, the sister of this formula. Now, it starts with the theorem of Pythagoras. Okay? R squared is equal to x squared plus y squared. Okay? Now, remember, on the previous page, I had written this down. I said y is equal to r sine theta, then y squared will be equal to r squared sine squared theta. Okay? I'm just using my knowledge of algebra. I'm not doing anything complicated here. Right? Also, x is equal to r cos theta, therefore x squared will be equal to r squared cos squared of theta. Okay? So I'm going to use the squared equation because it's related to the theorem of Pythagoras. So where there is x squared here, I'll substitute by r squared cos squared theta, which is what I did here. Okay? And where there is y squared, I'll substitute that with r squared sine squared theta, which I did there. Okay? I'm just playing around with the equation that you already know from last year. Okay? Then if you simplify, you get r squared cos squared theta, which is the same as this. And that r squared times sine squared theta is the same as that. Okay? Then we have a common factor. The common factor is that. We take out the common factor, we end up having r squared times the sum of cos squared theta plus sine squared theta. Okay? Then if you divide both sides by r squared, you get 1 on the left is equal to cos squared theta plus sine squared theta. This is the second fundamental identity. It can also be written as sine squared theta plus cos squared theta equal to 1. Okay? This is the fundamental identity. It can also be simplified. So I simplified it. It can also be written in two other forms, whereby you can make sine squared theta the subject. So you take the cos squared theta to the right, you get 1 minus cos squared theta. 1 minus cos squared theta is equal to sine squared theta. Furthermore, you can take the cos squared theta, you can take the sine squared theta to the right, you get cos squared theta is equal to 1 minus sine squared theta. Okay, but the main one is this one.
Sir, the answer always 1.
Yes. So if you add sine squared theta plus cos squared theta, you always get a 1. For any value of theta. Whether theta is acute or not, you always get a 1. Alright? Okay. So they're supposed to be a square. Right?